Hey,
It's
gang,
live. What's going
I
on?
think I'm ready. We're ready.
Yep.
On behalf of the gents on the Zoom screen with me, ladies and gentlemen, I'll introduce you to them in a moment. I welcome you to the SBAU Astro Hour. It's our 245th program of cutting edge cosmology and astrophysics for the Longtime Telescope Club for our town, Santa Barbara, California, the SB Astronomical Unit. I'm your host, proudly, Ronnie Herron. Glad to be part of a great organization that's headquartered up at our beautiful Santa Barbara Museum of Natural History, where we hold our first Friday general meetings. That'll be this Friday night, the 7th, with Dr. Kornut, Caltech, talking about a launch back in March called SphereX. Second Saturday star parties will be the next day. Want to check us out? Go online, sbau.org, and then come enjoy one of our museum's planetarium shows. We'll have one before our meeting this Friday. This week, the Brain Trust and I will plumb the depths of these astral topics, ladies and gentlemen. Still talking Halloween, spooky, with an open star cluster in Cassiopeia called Ghost Goblet, and some other cosmic scaries. There's a phenomenon called pareidolia, and another young cluster still in Cassiopeia is M103 near Delta Cas. What's the time scale for a nebula to form an open star cluster? It's got to be a while. We get a full beaver moon this week. It's this Wednesday morning, either 5:19 PST or 4:19 PDT. I'm not sure where we stand. I think we're in DT, daylight time. We'll work that out. We'll tell you why only this coming December's full moon can be considered a supermoon. What's a ray system? Anyway, we've got a picture of meteorite strikes on planets and moons, lots of them to show you. Not to be confused with ray optics or Ray Bolger, the scarecrow for that matter. Somehow astronomers have come up with a 3D map of an exoplanet. Wow. Wait till you see the spooky picture of the sun. Speaking of spooky pictures, let me introduce you to the gang on screen around me. Our beloved president and commander of the Starship Astro Hour, Jerry Wilson, is there. Jerry, hello
Good
again.
morning, everyone. Good morning to my sister Joyce and to Calvin and Riley.
That's right. And your lovely wife, Kat Forgy, there lives with you. And I just learned that a lot of the people I went to school with in middle school and high school 1 year up in Southwest Washington State are watching us because I get these CC things with 47 people's names, and I finally just told them I'll wave at you guys, so we'll see if they're watching us. So he's married to a Pat, and so is Chuck McPartland, our Santa Barbara AU outreach coordinator. Chuck McPartland, in charge of most events. You think you'll be able to set up your telescope this coming Saturday night? Chuck, is your back okay?
Oh yeah, that's fine.
Okay. Well, it was a strange sight seeing just you with your 5 pound pet rock last time we had a star party. And Pat McPartland, his wife, is our beloved merchandise manager, and doggone, she also runs the treasury department. Who else joined us? Early on screen was Bruce Murdoch, who is an enthusiastic member of our club. Probably has more socializing and fun with us than he does with the Santa Barbara Theater Organ Society, which he runs. But we need him. His wife is Bonnie, and I hope she's doing well. We have been joined by let's see, Tim Crawford, resident lens and telescope expert. Hiya, Tim.
Hello, howdy.
Yes,
Wow, Tim, where'd you learn all that?
and his wife is Karen. And let's see, Tom Whittemore. Here we are, ex science professor out of Westmont, is our newsletter guy. Married to Maureen,
Astronomy.
having his coffee and baking us all the bread we're going to get for Christmas. I'm not sure if everybody else got more than the two I got, the cartoons, but we do silly science.
Oh,
cartoons.
yeah, that's right. I sent you guys two yesterday. Those are not in today's. I have 7 for today that I
All right. So my
send
little
out.
comments were just going to be ad lib off the cuff, and all of you are welcome to join in here. So we start the day with a little hourly levity. The show features got a companion of old Larson's Far Sides and Calvin and Hobbes. So here we go. Brewster Rocket, the space guy. You want to run us through this since you're familiar with it, Mr. President?
It's a SETI, Search for Extraterrestrial Intelligence.
Okay.
And it says we got a transmission from space. It may be a message from alien species. We may find out about extraterrestrial life forms. They may reveal to us the secrets of the universe, answers to solve the world's problems. Oh no, what's wrong? Is it a threat warning? Is it a threat, a warning? Oh no, first we have to sit through a stupid ad. Can we skip it after 5 seconds?
Like YouTube videos? That's
Yeah.
funny.
So
Okay.
this is
that a
the
regular thing?
Populator 3000 they're selling.
Brewster Rocket. I think it's high time we make movies of Brewster Rocket. All right. This one shows a couple of aliens, monstrous size, right? In the distance
Right.
of one of our cities.
And
Who
they're
wants
throwing
to-
rocks at a city, and all of these planes are starting to swarm around it. And one of them says, ooh, that one got them stirred up. Zangorn, let's blow.
Okay. Lord, they could be big, come from a big planet. Okay, here's obviously what a fortune teller, a medium, or witch on the psychiatrist couch,
Yeah.
telling all you. Who wants to read it? Tim, how about you?
Okay, reading people's minds is deeply disturbing. I mean, there are some things even I don't want to know.
Okay.
And this is called ESP PTSD.
Oh, I see. ESPTS. Extrasensory
Perception,
perception. Okay.
post-traumatic stress
Extrasensory post-traumatic.
disability.
Remember, what was that fortune teller we had around town? Is she still around? She had the little shops all over Santa Barbara.
Yeah, I don't know.
It was
I don't
one
think
of
so.
those-
Maybe still out on the wharf.
Maybe.
Yeah.
Oh, really?
Cinco.
Yeah, Madame Lozenko. I remember her. I never went to her.
Rosinka.
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 Yeah.
You're gonna have to enlarge that one. It looks like a. Oh, we got it. I'll tell you what it is right now. Heard about this my whole life. There's a fork in the road.
Who was that Yogi Berra that said, if you find a fork in the road, take it?
Take it.
Yeah.
Or watch out, you got a flat.
Yeah.
All right. Chuck, why don't you read this one?
Halloween at the International Space Station. There are various astronauts floating around in strange positions, and there's a knock on the door, trick or treat.
Nobody's afraid to open it.
Halloween at the ISS. Okay, Mr. President, you want to guide us through peanuts? Charlie Brown
Okay.
talking to whom? That's
Um,
Linus, isn't it?
Charlie Brown is explaining it to who's
Linus.
Linus.
After kindergarten, you go to school for 12 more years. Then you go to college for maybe 4 or 6 or 8 more years. Then what? Then you can do anything you want. Oh, how nice of them.
Linus, the one with the blanket,
Yeah.
Yes.
Yeah.
just doesn't happen to have it in this. Okay. Okay. How about you, Tom Whittemore? You feel like
It's breaking up here. I can't. It looks like working alone.
Yeah.
Okay. Professor Dawson stumbles into a bad section of the Petri dish. Now put the wallet on the counter.
He's being held up.
Oh.
the Petri dish is coming alive and becoming AI or something, right? Okay. Well, that got us in the mood. Now let's go to the serious stuff in the sky. Always something new. It's just amazing. We don't even get through all of it sometimes,
That's okay.
but that's okay, right? There's the sky.
Okay, so this is today at 7 p.m. and we're looking here. This is a early evening, and it is dark at 7 p.m. nowadays.
Mhm.
Yes, it is.
The moon is up here. It's not quite full. And this is NGC 599, I think. Let me look. Yeah, NGC 559, also known as Caldwell 8. Caldwell is a catalog developed by Stephen James O'Meara.
No, it was
Oh, no.
it was the British guy.
Right.
Oh, that's right. Patrick Moore.
Patrick
yeah.
Moore, the
That's
moon
right.
guy.
And he didn't want to call it he didn't want to use his last name Moore because then it would have conflicted with Messier. So he called him Caldwell.
Mm-hmm.
But this is one of our dodges of getting away from the bright moon, which destroys our look at faint fuzzies like M33 over here or the Andromeda Galaxy. So it's easier to look at open clusters. And this open cluster is located in Cassiopeia. Here's the W of Cassiopeia, and here's the pole star, Polaris. So it's about a third of the way between Polaris and the moon. So it's enough distance you can actually see it. And this is a photograph of it.
It's nice.
And this one, Stephen O'Meara calls it the Ghost's Goblet. And as near as I can tell, this is the stem of the goblet, and these two lines are the glass martini glass. And that is the goblet for him.
Not
Anyone else see
goblin,
that?
not
Kornut.
goblin, but goblet.
Goblet.
Got it.
You guys see that?
Yep.
You could have a good imagination.
Where's the stem?
The stem is kind of shortchanged, but it's sticking down here.
Unless it goes all the way down.
I see a thicker stem and a bigger goblet, but yeah.
Where is that? Where's the stem?
So it's where you were, but
Oh.
but it's wider and comes down farther.
Oh,
So
like
down even more, down to there, yeah.
Would that
And then there's a
include
much bigger goblet, U-shaped goblet at the top, even higher, yeah, up to that bright star there, yeah, and then on the other side.
Okay. Now, when Stephen looks at things that usually visually, and when you look at it visually, you get different impressions than in a photograph. The photograph picks out more stars and confuses the simple thing you see. And that gets into part of our today's talk.
Yeah.
It's why we put together shapes, our eyes and brain put together familiar shapes in the sky. And we will talk about that in a minute. It is, Chuck, you know the name of it.
Pareidolia.
Pareidolia, thank you. Yes.
Pareidolia. Huh.
Now, in addition to that, this is a young star cluster, which means that it came from a nebula. Then the nebula and the stars were together in what we call a stellar nursery. And then as the stars turn on, their solar winds blow the rest of the dust and gas away, and you're left with a with the star cluster. And so that it takes about 100 million years to go from stars to this, and these last about 100 million years, which in astronomy is a very short time.
from stars to that? I didn't understand it. You mean from the dust to that, right?
Yeah, this is the previous stage. This is
Okay.
trapesium in the Orion Nebula. And this is the stage where the stars are forming, but there's still dust around. And the stars, their bright, hot winds are tending to blow the dust away. You can see the dust is getting structure around here where individual stars are starting to blow it around and make holes in it. And pretty soon they will get rid of all the dust and you'll just have the star cluster.
Can I get an idea of what dust is made of? I mean, there's hydrogen atoms, right? What's the rest of it? What's the dust? Is it all the other elements or just helium?
It's carbons and silicates, yeah, just small pieces of stuff.
Okay, so it has to be the aftermath of an earlier star nova, an explosion.
By now, yes. What the Earth is made out of, dirt, is what the dust is, but very fine.
Dirt.
But the original nebulas were just hydrogen, weren't they?
No, it just means cloud.
Yeah.
Can you see just hydrogen by itself? Does it connotate itself as dust?
Hydrogen fluoresces pink. That's what you see as the reddish color.
Yeah, up here.
Even though the atoms may be very far apart, floating around.
Yep.
There's just so many of them along your line of sight.
Yeah.
Got it.
Gary, back when in about 1969, I was clearing one of these golf courses from a flood in 1969, and I called something dirt, and the guy got really mad at me, and he said, It's not dirt, it's soil.
Sod.
Now this is another open cluster that we could find.
Yeah.
It's the Christmas tree cluster.
Christmas tree.
That's about a month early on that one, but
Yeah,
Is
this
it upside down?
No, it's right side up.
It's fine.
Okay.
Uh-oh. Okay.
This is M103.
Mm-hmm.
It is 25 million years old.
It's young.
So these things are short-lived. This has gotten rid of all of its dust around it. It's got some really hot white stars in here. This orange giant is probably in front of the cluster and not part of it.
Mhm.
And so let's see, yeah, okay.
is it small? Is there only a handful of stars in it? Just
Yeah,
those
it's
big-
pretty, it's probably 100 or 200. Let's see, does
Oh.
it say, do I say, yeah. It's 8,000 to 9,000 light years away. Doesn't say the population of it here in my notes.
So that's like the next spiral arm out.
Yeah,
You know, this doesn't do justice to that object, because in the telescope, at least in my telescope, when I look at it, the Christmas tree, the conical part of the tree is very well defined.
yes, I find that to be true too. But like we said, there's too many stars here now and the pattern is broken up.
Yeah, yeah.
Well,
Too much processing.
Right.
There's some names given to those big bright ones we're looking at. There's only about 4 or 5 big, huge, bright ones in the middle.
Top and bottom.
There are names
Well,
for them.
yeah. They're all going to have some catalog designation.
Is that right? Even though the whole thing together is M31.
M103.
Oh,
103.
M3. M31 is Andromeda.
That's what I just realized.
Yeah.
Yeah.
Now, the fact that we can make a goblet out of it and a Christmas tree out of it is an example of the pareidolia, which the human eye does. And this is an example of that.
That's our sun. Boo.
Yes, this is October 8, 2014.
Give
The
me a
Solar
break.
Dynamics Observatory took a picture of the sun. The shot combines 2 images taken in the extreme ultraviolet and with the far shorter wavelength than our eyes can see, which highlight magnetic activity and appears to be a face. So that's the first thing we spot. And that's the way our brain processes images. They look for familiarity and patterns. Then they look for geometric shapes and stuff. Your eye can pick out a straight line out in nature right away because they don't normally occur. They do occur, but they don't normally occur. They're not common.
Got one exactly like it on the porch next door, rotting away.
Yeah, our pumpkins end up looking like this. This one is an asteroid. 2015, an asteroid passed just 485,000 kilometers from Earth on Halloween, no less. It looks eerily like a human skull. 2015 TB145. The asteroid is about 600 meters in diameter and won't pose a potential threat to Earth for at least 150 years.
Huh. Top part of the skull and mandible missing. Okay.
Yeah, the lower jaw is missing. Nose, eye sockets, cheekbone.
What's the white crescent mean?
Cranium. That's where the sun was.
Oh.
He's
Okay.
bald.
Yeah. Well, it's a skull. No skin.
Is this indeed?
It took a movie of this one when it went by in 2015 and sent it off to Ed Hat.
Oh, did they? They published it?
Yeah.
How did they publish a movie? Just one frame of it, or?
I turned it into a GIF.
Oh, okay.
Definitely looks like there's 2 eye sockets there.
Yep.
There's another one. Boo.
Here's another one. Now,
Dreaming
this one-
Mimi.
This is a planetary nebula, giving a creepy skull look to it in the windstorm. A star dies and ejects gas into space where all the elements are superheated by the core of the star. In the image, oxygen close to the core glows blue, and the cavities in the eyes and mouth are likely sculpted by the interaction of stellar wind with the environment around the star. The overall skull shapes arises farther away from the star as the oxygen glow fades.
Wow.
So it is a planetary nebula. There is a star in the core of it. Could be that one. That's about the centric, this little white one. So that's the white dwarf at the end of it. And apparently it's got some motion, some stellar wind blowing these things away.
Can you clarify something for the host, Mr.
Go ahead.
Benz? Can a planetary nebula spawn a future star cluster?
It contributes to them, but they're usually a lot denser, a lot more tenuous.
Okay.
Yeah, this is from sort of sun-like stars, so that's not a lot of massive stuff.
Huh. So this is following an explosion of
Well,
one star?
no, not
What's
really
going-
a violent explosion, but a poofing off of the outer layers of the star.
One star or several?
One star.
Nebulas are pretty big, aren't they? Don't they span light
No,
years?
nebula just means cloud, Ron, and this happens to be a small cloud, a planetary nebula, from a single star that's low mass like our sun.
But aren't all nebulas light years across? They're not just like a solar system size, one star.
No, it just means cloud. They can be just about any size.
Yeah.
For us to see them, they have to be pretty large.
Planetary nebulas will start as a solar system size cloud.
Yeah.
They will. Okay.
So anyway, my vote is I think that's the culprit.
Yeah,
looks good.
I think you're right.
Nice and hot.
Now, there are lots of things on the moon that we see, patterns and stuff. We're not going to go into that. We did at a previous one a couple of years ago, looking at the scissors and the spectacles and the straight line and the X, all sorts of things.
Yeah.
You have to
The
catch
lunar X
time.
is only there for in a few hours, and then it goes away.
Yeah.
Huh.
Now, this moon, this is I believe this is November 5, Wednesday at 5:19 a.m. This is the full moon rising or sinking in the west. It is in Aries. It's just below the Pleiades. This is in the early morning. So it's because it's the full moon, it's been up all night. And so it's giving up the ghost here.
Would this be the one Leslie Nielsen in the Naked Gun movie once said, I think to Priscilla Presley, "Hey, nice beaver."
Nice beaver. No, that wasn't referring to the moon.
I know that, but is that what this is called?
This is called the beaver moon.
Well, nice beaver.
Yeah.
Like, give me a break. Why the beaver moon? Is this time of this year that they harvest beavers or something?
I have no idea where these are historical names from Farmer's Almanac and Farmer's Lore out. They used the moon in old times to time things, to time planting seasons and harvesting seasons.
And
when to hunker down for winter.
You're about to tell us why it's not a supermoon here in a minute, aren't you?
No,
it is
a supermoon.
Oh, this is a supermoon?
Yeah, because it's big. It's closer to Earth than normal.
What's on the close?
That's the beaver that named it.
Yeah.
Now you can see at the full moon.
Tim, his name is Eager.
Eager, yeah. It used to be Edgar.
Eager the beaver, Eager Edgar.
So you can see here the full moon is fairly featureless and very bright. These are bright features. And you pick out the thing that stands out that you don't normally see when there's a terminator on the moon, is you see these ray systems.
That Tycho is really visible.
The what? Oh, Tycho?
Tycho. Yeah, down at the bottom.
Ray systems we're adding into there. There we go. Okay.
Now these are prominent, some of the prominent ray systems. They left out this one up here and several other ones. There's a ray system there where this ray comes down. But the major ones, and I couldn't go back. I wanted to go back and find what names these numbers corresponded to, but we'll just have to realize that ourselves because I couldn't find that page again. So, but these are very striking ring systems. There is a faint one here. And these are, what's happening is that an impact has occurred, and it's a relatively recent impact in geological or astronomical time. And the surface of the moon is just sitting there all the time, and it's being bombarded by the solar radiation, which is basically protons. And it gets colorized, it develops a certain color, it gets radiated. And so when something hits, it breaks through that radiated layer, which has a certain composition and presentation, and it gets into the material underneath, and it spatters that underneath material out there, which has not yet been radiated for a significantly long time. So it's usually a different color depending on what's under there. Most rays we look at are whiter, but there are cases and wavelengths where if you look, the rays are darker material. But these are bright ones on the near side of the moon.
Are the rays dug in like ruts, or is it just like splattered paint?
It looks
So
like
what's the boat?
yeah.
Yeah.
So
The impact is dug in, and the ejecta is plastered on the surface.
Yeah.
okay, that ejecta would have been lava, molten at one point.
No. Well, rocks, basically,
okay.
chunks.
It's dust, yeah.
Yeah.
In fact, there's a spot up by number 7, but I don't think it's number 7 there, where it actually, some big chunk of stuff blasted its way through a ridge,
That's right. Yeah.
and it made that Apennine Valley.
Yeah.
You can also tell, number 1 was a high-speed impact. That's Tycho,
Yeah.
because the rays were straight and long. And then number 2 was, I think that's Copernicus, and that's
Copernicus, I think, yeah.
It's
right,
Copernicus.
but it was low speed because it's in a telescope. It's a lot more visible than here. All the rays are wiggly, and so the ejecta rolled around. It didn't get splattered out straight.
Yeah, you can tell the impact partly by the pattern of the rays. If it's very asymmetric, it came in at a lower angle and spattered one way. Now this one, it came down, but there was something there, another crater wall or something that prevented the spatter in this direction.
Yeah.
And that's a little blown out in your image, but in the image,
sorry.
in
Yeah.
the
So
pocket
Chuck,
point, it shows up better.
Chuck, is that Proclus? The one there?
I don't know enough about the moon.
Yeah, near Mare Crisium. Yeah, it's right on the edge of Mare Crisium.
Yeah.
The Bay of Crises.
Yeah, that's Proclus.
There we go.
That's a beauty. That's a beauty.
Yeah,
Is
this
3
shows it all
Ptolemy-
much better.
Is 3 Ptolemy?
Ptolemy?
Yeah.
Ptolemaios? I don't know.
No, isn't this Ptolemy?
I
Well, maybe
think
it is.
so.
3 could be Gassendi, possibly,
Oh, okay.
because that's a late feature. Like 11-day-old moon, Tim.
Yeah.
Okay, now the following is not a full moon picture.
Mm-hmm.
It looks weird, but it's the same moon spots.
Mm-hmm.
You can see a little bit of rays. What this is a trick photography, so to speak. This is a composite picture taken of the terminator every couple of days as the terminator moved across the moon. And the thing that distinguishes it from a full moon image is the fact that these craters have shadows in it. And if it were the full moon, the sunlight would be coming straight down and there would be no shadows on it. So this is a picture of the moon compositely made to show features that are easier to identify because of the shadows.
But did the rays go away?
The rays are there, but you can't see them because the sunlight is at a different aspect angle, so it doesn't emphasize the rays. Here you can see there's faint rays because this ray is so bright, but there is shadow in the moon, so it's not going to show the ray system. Wish that tag wouldn't come up.
Ronnie, the reason the rays show up more prominently on a full moon is because the mineral that's being excavated and sprayed out is called anorthosite, and it has tetrahedral crystals, and they're very good at reflecting light directly back in the direction that it came from. And so at full moon, they show up much, much brighter.
And that stuff only exists under the top layer. It's
Well,
just
no, it exists all over the highland, the bright areas on the moon. So that's why it looks quite a bit brighter when it's full. But it's been dulled a little by the solar radiation, like Jerry said.
And in a billion years, these rays will fade because the photon radiation that they're getting will destroy that crystal structure.
Okay. Does this same phenomena we're looking at with rays exist on Mercury?
Yep.
Same thing.
It's not the same mineral, but you get the rays because of the splats.
How about ice moons?
You also see sprays from those, but you don't get that super brightening effect from direct rays of the sun.
This is a close-up of Tycho, one of the most prominent rays we saw in the earlier one. And you can see the spatter pattern going out here. It hits this side of these craters, these ridges, and shadows them a little bit from it. So it's a very distinctive pattern. And this is during a full moon. Now this is Giordano Bruno, and this is taken from Apollo 11. And that's this ray system up here, which goes way out. It was apparently a very high-speed impact. There's other ray systems going across, and this was taken from very close to the moon.
Was he the guy that was burned alive?
Yeah, 1600, Tim.
Wow. Oh boy.
At the Campo di
if you or
Fiore.
I went back in time, like in the story Connecticut Yankee and King Arthur's Court, my theory is that if you went back there in the morning, by the afternoon, you would either be locked up in an insane asylum, or they would be lighting the fuel around your feet as you were chained to a stake.
Yeah.
Because of what you knew that just wasn't so.
Yeah.
Right, Tim, he was executed at the Campo di Fiore in Rome. You know, the field of flowers, that wild.
Oh God. How poetic.
Yeah.
And it was for saying that there probably are civilizations and life out in the universe.
Right. That's right.
I didn't mean it.
Yeah.
Well, this really shows the rays, doesn't it?
This does. Now, this is the Kuiper crater on Mercury.
Wow.
So this was taken by a messenger spacecraft. Doesn't say the date, but anyway, whenever it was up.
It's interesting that it's called Kuiper because crater systems on Mercury are usually named after artists or musicians.
Really?
Yeah.
Well, we have a belt named Kuiper, don't we?
Yeah.
We do have that, yes.
Maybe there was a musician or artist I don't know about named Kuiper also.
Wow.
It was a common name back then, you know.
Yeah.
Yeah, we had an engineer at work whose last name was Kuiper. Spelled the same way.
Yeah. You say he was a classy dresser, Ron. Did you know that?
No, but
Yeah, he wore a Kuiper belt.
You know, I heard that Orion was disappointed with his belt when it arrived.
oh,
They gave it 3 stars.
only 3 stars. Okay. Chuck, when did I lose control here? Do you remember?
Control is a pipe dream of this group.
That's true, right?
Okay, this one, anyone want to guess the planet?
Mars.
Mars.
Okay.
Oh, this is the one you talked to me about yesterday.
This is 30 meters in diameter, formed between July 2010 and May 2012. So it's a brand new, fresh impact crater.
Wow.
On Mars.
Yeah, on Mars.
It's not that red, or maybe it is.
You never know about astro colors because of their, that they're all basically false colors. You weren't there. But yeah, this is just the fact that there's underlying material now overlaying the topsoil. And that's just different colors. You can't really tell that it's maybe the same crystal structure, although it might be, or a similar one.
Can I make a comment about how it looks? You've talked about angles of these incoming rocks. That looks like it's a direct hit rather than at an angle. Wouldn't the crater be more obloid or?
No, I see it more as a oblate like this. So it was very straight down, but slightly more this way. You see,
Ronnie, they have to be really, really at an oblique angle before you see that, because when they hit, it just vaporizes and becomes a big explosion. And so the craters still tend to be very circular unless it's a really shallow angle.
Right.
Have you ever taken a flat rock and skipped it across water? Do you suppose there are some flat Oumuamuas that come into the planets and do that across?
Well, there's one that skipped off our atmosphere in the 70s that people got images of.
Yeah.
I know, but there's a strange phenomenon going on.
When I was about 10 years old, we went to a Griffith Observatory show. And my friend and I came home and we made a big mud puddle in the backyard. And with spoons, we threw droplets of mud into the mud. And we noticed that we could make all sorts of craters with that. And at the end of the day, my mother told us not to do that anymore.
There's a display that is used in the Night Sky Network. And I know Chrissy does it a lot at the local schools when they have a science night, is you take flour and cocoa powder.
Oh, yeah.
And you layer them so that, you know, one or the other is the dominant one on top.
Yeah.
And then you throw things at it to make the craters, and you can see how the stuff below gets excavated out and sprayed.
Yeah. That's very good. I was invited to give a short talk at my grandson's kindergarten class on astronomy.
Kindergarten.
That's tough.
Yes, it is. I've been worrying about it for days now. And I think that, knowing my grandson, I think that making a demonstration of these ray patterns with what you just said, the two powder colors, mud, I think that's on the agenda there. Something they may remember.
You could put some tang in there too. That gives you orange.
Yeah.
When is that going to happen, Mr. President?
No date has been set.
Oh, because we'd all love to show up, I'm sure.
I don't. Yeah, and I'm going to talk to Chrissy about it because she has a real knack for speaking to children. I can barely pull it off with you guys. Okay, this is a set of strip photographs put together. An ensemble. This is by the Themis detector. It's taken our Themis satellite around Mars, which I helped build. And these are, it takes a picture using its orbital motion to scan, and then the images are put together. It's in the infrared, and this is at night. And this is a crater called Gratteri, right there. And that to me looks like it's pretty much straight on. But this shows that the crater, the things here are dark on a lighter background in the infrared. Now that's going to be for probably different physical reasons than the color you would get visibly if you were to see this. But I put it in there to show that not all craters or not all rays are white. But this is in infrared, so it's going to be a whole different definition of white.
But the long black bars mean that didn't get a picture, did it, right?
That's right. That's right.
Boy, that's a lot of orbits to assemble an image.
Yep. Don't want nothing to move.
Yeah.
Or if it does, you're in trouble.
Well, it could be something very interesting.
Yeah.
We're looking at a big crater almost the size of the picture rather than all these little ones.
No, we're looking at the crater is here in my view, and then these are rays around it here.
Oh, I see. I got you.
So this might be a central peak, and these are the crater. It's hard to tell with this missing strip here.
Well, the other things could be older craters with the ejecta over the top of them.
What was it you did to contribute to this project, Mr. Perez? Just curious. You remember? Can you be told? Can you tell us?
We don't make the whole spacecraft. We make the camera that goes on the spacecraft.
That took these pictures?
That took these pictures, yeah. So,
Wow.
and we have different groups. We have the focal plane system, and I'm usually the focal plane engineer, which makes the detector chip. And then we grow the crystals, we design the detector, we do lithography to define the crystal, the detector, the pixel area and stuff. We design, and then the electronics group does the readout, the ROIC, readout integration chip. And then we have Optomech that does the optics and the mechanical things for focusing and pointing. And I usually do the integration of the chip itself, design the chip, supervise making the chip, and then integrate it with the readout integrated circuit, and then do the testing, supervise the testing. But these are, when I say I made this, these are large groups of engineers. I don't mean to say that I'm in there by myself with a hammer and chisel.
But that pretty much paid for your house now that you're living in, didn't it?
Yes, it did.
Bless your heart.
I keep crashing out, you guys. I may have difficulty getting back. I don't know why I'm crashing, but it's happened twice.
Mine goes all that time like that. Yeah.
Okay.
Now, I just put this in as a joke. This is not to be confused with, that ray system is not to be confused with ray optics, which is a method used to design optics. And these are simple optical shapes. And it shows how light rays act when they hit that. Here's just a flat lens. It's actually a flat piece of glass. And the light comes in, and if it's hitting at a normal angle, it goes, and that means a 90-degree angle here, then it goes straight through. If you tip this piece of glass, then the light will bend a little bit and then come out the same way. It'll be coming the same way again, because there's no optical power to it. This is a concave mirror. The light comes straight in. And these light, when it comes straight in, is referred to as a, excuse me a second. Tarzan. The light comes in, it's called a plane wave because it's actually from a point source at the star, but the star is so far away that the light rays are essentially parallel. So that's a plane wave. And this is how a concave mirror would reflect that. In order for it to come to a single point, this mirror has to be a parabola. If it were a spherical shape, it would focus along a line called a caustic. The big radio telescopes like our CIVO and the one in China, they focus on a caustic, and that's why it has a long antenna hanging down to get all the radiation that's.
Interesting.
This is a concave lens. This is what I wear on my glasses because I'm nearsighted. So the light comes in and it scatters out. And this is also a Barlow lens, which adds optical power to your telescope. This is a convex mirror, which is frequently used as a secondary in Schmidt-Cassegrains, like who's that? Meade, and the other one is Celestron, yeah. And so the light there is actually traveling out, or traveling, it's coming to a focus like this. So it's actually going this way toward the eyepiece. But if it comes in as a plane wave, it hits this and it scatters out. This is a convex lens, and if you're farsighted, then you would get this to bring in the light. The light comes parallel in, and this is like the objective lens in a refractor.
My next pair of glasses is going to come with a neck brace. My eyesight's getting.
You need a Chase Lounge.
Can I point out what's missing?
There's a lot of things missing here.
The triangular shape of a prism that gives you colors, the rainbow. I've always wondered, how does a triangle divide up? Does it have to do with the same thing here?
None of these, this is just geometry of a single wavelength. There's nothing here about dispersive light, which means that lights of several colors come through. Because when you go through glass, the glass treats each wavelength as a different thing. And so when it comes through, say, the lens here, it doesn't, all the wavelengths don't come out like this. Some come out at here and some come out there. And so you get false color, called chromatic aberration from a single glass lens. but you don't get any chromatic aberration from a mirror. They're always perfectly aligned or perfectly coincident in the different focus.
That's because the different wavelengths as they're going through the glass, it's as though they get slowed down by different amounts as they go through the glass. And so it spreads it out because the angle that they come out is a little different.
Exactly.
Would a second surface mirror get a little bit of chromatic aberration?
It can a little teeny bit. Yes.
Well, it's a good double image.
Oh, okay.
You can go all sorts of nuts on badly designed telescopes. There is a very thin but complex curved window at the entrance to a Schmidt-Cassegrain telescope that corrects spherical aberration. And there is a teeny bit of chromatic aberration that adds, but it is insignificant. You can't find it in the focused image.
Oh, okay.
Can I ask a question about glass? Is it made of just one element, silicone?
No.
What else is in there?
Silicon, Ron, it's silicon. Silicone is a totally different thing.
I understand. I mispronounced both.
Silicone
Silicon Valley. I've never read. To me, there's
Silica, S-I-L-I-C-A, silica.
Yeah.
Silica. But
these are made out of various different things. The mirrors are frequently made out of ceramics called Cervit or Zerodur or Pyrex. You wouldn't make Pyrex for a lens because it colors it. The lenses are made out of various different kinds of glasses. They have different dispersion curves. And when a light comes in through a singlet objective lens, the light, different colors scatter and come to different focuses. So you put different kinds of glass lenses behind it that put the light back together before it gets to a focus.
Yeah, didn't they come up with it was flint and
Crown.
Yeah,
that's the Fresnel optics formula. And
that was the first
thing that was when they learned how to make flint secondaries or flint lenses, then they could make achromatic lenses that had no color, but that it's only two elements. So you get to have two light waves coincide at the same focus. They chose red and yellow or green, and the blue tended to make a violet halo around it. It had a slight color. So you made the telescope really long, like F16 or F22, in order for a doublet to form a color-free image. But now we make 3 and 4 and even 5 element lenses that bring many wavelengths to a very sharp focus. And they're like my Nagler Petzval from Teleview has 4 elements in there. And that thing is just crisp and sharp. It is an incredible telescope. I bought it because Sky and Telescope reviewed it in 2001. And they said, as for aberrations, there are none. So I thought, I've got to test that.
Yeah.
Got NP101, and it was just beautiful.
And some of the early telescopes that had only a single lens of a single kind of glass, if you made them longer focal length, you started to get rid of the chromatic aberration. So some of those telescopes were 300 feet long.
Yes.
Yeah.
And you get down eventually to a spectral pinhole image or a pinhole optics, which has no chromatic aberration.
The soda straw.
So, it's pinholer than that. Okay, now this one is a little different story. It's interesting, and this is not the picture they took. This is an artist rendition of the mathematical description of the data they got. And this is an exoplanet. This exoplanet is mapped for temperature. So what you see is this is one of those gas giant planets that goes around its sun in 23 hours. So it's very close to the sun. So it gets very hot. And what you're looking at is water in the atmosphere. And this is where the atmosphere is about, let's see, it's something like temperatures in the planet's atmosphere reach nearly 5,000 degrees Fahrenheit. So that's this light stuff. They can map the temperature of the water in the atmosphere of this planet. And it always keeps the same side to the planet as it goes around.
Tidally locked.
Yes, it's tidally locked, but they can do a 3D temperature map And they do it because this is an eclipsing planet. It goes behind its sun. And when it's going behind its sun, you'll see part of it sticking out. And so you get a signal from the part that's, say, cooler. And then later it's more of it sticking out. So you get a signal from the cooler part and the slightly warmer part. And then you get the radiance from the cooler part, the slightly warmer part, and then an even warmer part. So as it's going behind the sun, its sun, or coming out behind it, the signal during that transition, you can deconvolute that to give the mathematical distribution of temperatures along that line. You're probably going to hear more about it, but this is really only applicable to very easy to read systems like this.
So very high resolution telescopes.
Yes. Yeah.
Now, is that what's creating these ring-like features that are running vertically?
That is possibly it. I would guess that this is more an artifact of the math that's done to deconvolute it.
Okay.
Deconvolution is a tricky process. It's where you actually measure the integral of something, but you try and figure out what the distribution was that all added up to give you that signal. And there can be artifacts showing up.
But you said this was a gas giant. Is the gas water vapor?
In this case, they're focused on the spectral line for water.
That doesn't mean the whole atmosphere is water, Ronnie. It just means that there is water in it.
Yeah. This is done by the James Webb Space Telescope. It's called spectroscopic eclipse mapping. And this
aren't they saying that rocky planets that used to have water, like possibly Mars or Venus, lost it a long time ago because of the rising heat, at least in Venus's case? And I'm wondering why this still has any. Why hasn't everything?
Ronnie, the heat just vaporizes it and turns it into water vapor. So that's what they're looking at here. What breaks it apart is ultraviolet light from its sun, if you don't have a magnetic field to protect it or a thick atmosphere to protect it.
And it probably is losing whole water molecules to space because they just get so energetic.
Yeah.
Because temperature is motion of the atoms.
5,000 degrees is a lot higher than the boiling point, let me tell you.
It'll scald you.
I would imagine.
Okay, last item today. We're on time.
Pretty much.
Now, this is a picture taken. Let's see who took this.
It looks like a Webb
Space Telescope. And you can see the prominent feature in this picture is right down here. Can you see that thing down there? Anyway, it's in the next picture too.
So this big picture is a new star being born, or multiple new stars.
Yeah, this is
the jets coming out.
Are we looking at hydrogen because it's pink?
Yep.
That software thinks we're done, so I got to do this.
It does? You have AI running rampant in your system, Mr.
Oh,
President?
just that system. Yeah, it does. This is the cosmic question mark.
I'll be damned.
That's that feature I pointed out in the previous frame.
That's neat.
See, right? It's very prominent down here. You can see it right there.
Oh, yeah.
Yeah. And so that's this here. And this is about the highest resolution they have. They believe there are really good artist rendition of what this might look like, but I decided not to show those. This is possibly a distorted interacting galaxy and another galaxy that is doing the distortion or just passing by. So it's the cosmic question mark.
It's God asking why.
Oh, this is the Unitarian Universalist picture.
Yeah.
I'll bet you if you look far and long enough, you'll see all the punctuation marks in space somewhere.
Somewhere there will be either a question mark and an exclamation mark next to it, or there will be the nerd not.
Yeah.
I'll bet you have colons and semicolons and ampersands. I'll bet you they're all out there.
Yeah.
Far out. What's it made of? Is it a star or is it a nebula?
These are all stars in here. That might be a star. And that's a star. That's a star.
But
But everything else is galaxies.
Well, the question mark is a galaxy?
It's a
Couple of galaxies.
Apparently a couple of galaxies, yeah.
Oh, that I didn't know. Wow.
It's blurry enough that it forms a question mark. If you zoom in on it, it may disappear.
Good Lord.
And if with this pareidolia stuff, if you look at star clusters, there are groupings of them that form, the number 37 and a shark and the Eiffel Tower and all kinds of stuff. So it's kind of fun.
That was my last colonoscopy there.
Yeah.
What doctor did you use? It must have been mine.
Yeah.
But the thing that cracks me up is that people will put on Facebook panoramic pictures of Mars, and they'll slowly pan around, and then all of a sudden they'll pan in on something that looks like, an obelisk or something. People go nuts with this pareidolia.
I have a question.
Yeah.
This is from yesterday. I'm going to take an aside here since we're at the end. Yesterday, I was looking up about 2 o'clock in my solar scope, and I think I saw my first solar flare. It was and it was very bright, very long, and it was probably about 4 Earths long, maybe 5 Earths.
Yeah.
And it wasn't there before, and it lasted about 20 minutes and then was gone.
Actually, it looked like this thing down here.
Yeah.
But fainter.
Yeah.
Yeah, well, that's what they would look like.
Yeah.
Is there a way of checking if there was a flare there yesterday?
Spaceweather.com.
Yeah.
Okay. I'll do that because I had always told people I've never seen a flare, but I think yesterday, Jerry and I saw one.
Yeah.
Were you recording?
No.
No, but Tom was in the observatory. He had David's little PST, and I think he spotted it as well.
Yeah.
But you take single pictures. Can you take videos?
Sure.
Yeah.
Do it all the time. Matter of fact, that's the best way to get good pictures of planets and the sun and the moon is to take a video.
When I try to use my iPhone with the solar scope, that picture of that exoplanet that had the little rings around it, sometimes I get those rings in the images I take with my phone. And I think Jerry told me one time it was a lens flaring, I think. But
on that scale with the cameras we use, it's most likely a flare. You're not going to see something as detailed as rings around a protoplanetary disk.
Yeah, it's just it's really a strange phenomenon. I'm going to play. I think next time I'm going to bring this phone mate I have and try to hook up an iPhone to it and take some better images.
There on space weather, there was a significant solar flare and coronal mass ejection, but they're saying it blew up this morning at 2 a.m. So
oh no, yeah.
So that was 2, but the wrong 2.
Yeah. That's
hard to see. It's hard to see the sun at 2 a.m.
Yeah. Unless you're in a spacecraft.
Yeah, true.
What's the status on the star that's supposed to blow? T Corioli or Corona?
T Coronae Borealis?
Yeah.
It's still going low.
That is currently at magnitude 9.6, so it's creeping up.
Yeah, unfortunately, Chuck, it's in the western sky around where the sun goes down.
Yep. Yeah. And there was that prediction that it would happen on November 10th.
Oh.
Really?
So it's going to be hard for us to see naturally.
Right.
Well, we'll depend on Los Cumbres Observatory to give us good pictures of it.
Yeah.
Yeah, let's hope.
And Betelgeuse is still up there undisturbed, not doing anything, just waffling in space.
Puffing and blowing off.
Well, gentlemen, keep in mind we have a meeting on Saturday, the day after our meeting in the Herron Hall with Dr. Kornut this weekend. So
That's going to be crowded.
Yeah, it's going to be interesting. Astronomical Unit. That's it for this week's SBAU Astro Hour. Big meetings in the museum. And doggone, come join us for Dr. Kornut. SphereX. I finally got a picture of it. It looks like a small metal birdie, badminton birdie in space. He's going to talk about it. You can also see his whole speech to the Mount Wilson Foundation on YouTube if you get an idea of what it's going to be like this week. That'll do it for now. Number 246 is next week. How in the world do we say goodbye in astronomical ways?
Hasta nebula.
Hasta nebula, everybody.
Thank you, guys.
Bye.